In this video, I'll be going over the quotient rule and the product rule, and I'll be doing a few examples. So I'm going to start by explaining the product rule. So this right here is the expression or the formula for the product rule. So we use the product rule when we have two functions that are multiplying each other, like this one right here, 1 plus 2x squared times x minus x squared. So you have two functions and they are multiplying each other, and that's when you use the product rule. So this says that when we want to find the derivative of these two, we have to first take the derivative of the first function, so this one right here, then we just multiply that function by the regular g at x function, and we add it to the first function again, but just the regular one, and we take the derivative of the second function. That may sound complicated, but it really isn't. So let's do one problem using the product rule. So first we take f prime of x is equal to, so now we take the derivative of this first function like this. So the derivative of the first function is 4x, because we take this down, this exponent down, and we multiply it by 2 to give us 4x. And then we just take the regular second function, so x minus x squared, and then we add that to the regular first function, 1 plus 2x squared, and we multiply it by the derivative of the second function. So the derivative of this second function would be 1, because the derivative of x is 1, and this would be minus 2x. Okay, let's do another example. So this time, let's differentiate x cubed times cos of x. So once again, we have to use the product rule here, because we have a function here, we have cos of x multiplying by another function, x cubed. So we take the derivative of the first function, so we take the derivative of x cubed, which is 3x squared, and we multiply that by the second function, which is cos of x, and we add that to f at x, which is just the first function, so x cubed, multiplied by the derivative of the second function. So the derivative of cos x is minus sine of x. And that's the derivative of this function. Okay, let's do one last example, but this time it's going to be a little bit harder, this last example. Okay, so this last example involves three functions, so that's why it's more difficult. So it asks us to differentiate or find the derivative of y equals x squared times sine of x times tan of x. So instead of having two functions here, like in the formula, we have three, but we can still apply the product rule to this. So we take the derivative of the first function, so the derivative of x squared is 2x, and that multiplies the second function, which is sine of x, and it multiplies the third function, which is tan of x. And we add that to x squared, so the first function. We do not take the derivative of that. We take the derivative of the second function, so the derivative of sine x is cos x. So we multiply that, and then we just put tan x here, and then we add that to x squared times sine x, and we take the derivative of tan x for the last one, and that is secant squared of x. So this is the derivative of x squared times sine of x times tan of x. Okay, now let's do a couple examples that involve the quotient rule. Personally, I find that the quotient rule is more difficult than the product rule because it just involves more calculations, I guess. So, for this first example, we are going to be asked to differentiate (1 plus 2x over 3 minus 4x. So before I start this problem, I will explain the quotient rule formula. So to take the derivative of this right here, we have to first write the derivative of the first function, so f prime of x, and multiply that by the second function g at x. Then we subtract it by the first function again, f at x, times the derivative of the second function. You can see that it's very similar to the product rule, except this is a negative. And then once we've done that, you have to divide it by the second function, g of x, squared. And that's the quotient rule. So let's do this example. So f prime of x is equal to, we take the derivative of f at x, or the first function, so that's 1 plus 2x, and the derivative of that is just 2, and we multiply that by the second function, which is 3 minus 4x, and we subtract that by the first function, which is 1 plus 2x, multiplied by the derivative of the second function, so the derivative of 3 minus 4x is just minus 4, and that's divided by the g of x squared, so that's 3 minus 4x squared. So usually I'd leave this like this, I wouldn't simplify it, but if we simplify this we get an easier answer. So f prime of x, if we multiply this, 2 times 3 is 6, 2 times minus 4x is minus 8x, and then 1 times minus 4, or minus 1 times minus 4 is plus 4, and minus 2x times minus 4 is minus 8x, or plus 8x, sorry. Minus 2x times minus 4 is 8x, and that is divided by 3 minus 4x squared. So if we simplify this, we can cancel the 8x's, and we can add 6 to 4, and this will give 10 over 3 minus 4x squared. So that's the derivative for this function. Okay, let's do one more example for the quotient rule. So this example asks to find the derivative of x plus 1 over x cubed plus x minus 2. So we have to use the quotient rule on this because it fits the formula of the quotient rule, which is f at x over g of x. So essentially, if you see a fraction, chances are you probably have to use the quotient rule. So let's start this problem. F prime of x equals, we take the derivative of the first function, so that's 1, and we multiply it by the second function, which is x cubed plus x minus 2, and we subtract that by the first function, which is x plus 1, and we multiply that by the derivative of the second function, which is x cubed plus x minus 2. And the derivative of the second function is 3x squared plus 1. And that is all divided by x cubed plus x minus 2 squared. And that's the answer. If you found this video helpful, don't forget to subscribe and turn on the bell notification. Thanks.